Its unmistakable reddish glow, pulsing softly from the shoulder of the constellation Orion, is visible even to the naked eye. It's a celestial beacon, familiar, constant. Until now. Recently, something extraordinary happened. Something no one expected. The James Webb Space Telescope, humanity's most advanced eye in space, recorded a startling phenomenon. Betelgeuse had suddenly increased in brightness by an astonishing 250%. A change so dramatic, so swift, that it left the scientific community in awe, and perhaps a little uneasy. What could cause such a massive red supergiant, already 700 times larger than our Sun, to blaze with newfound intensity? What secrets lie within its turbulent heart? Betelgeuse is no ordinary star. It's a red supergiant, a dying colossus, nearing the end of its life cycle. Located approximately 642 light-years from Earth, it is one of the largest, brightest, and most studied stars in our galaxy. Its brilliance has long been a symbol of power, but also of impermanence, a reminder that even giants must fall. Red supergiants like Betelgeuse are inherently unstable. Their massive cores burn through nuclear fuel at a breakneck pace, fusing elements heavier than hydrogen in a desperate bid to stave off gravitational collapse. Over the years, Betelgeuse has fluctuated in brightness, showing erratic dimming and brightening cycles. But this time, something feels different. This time, the change was too sudden, too sharp, too profound. The James Webb Space Telescope, armed with infrared eyes that can pierce through the thick veils of cosmic dust, revealed what ground-based telescopes could not. It peered into the very soul of Betelgeuse. And what it found was nothing short of astonishing, a sudden, rapid, and unexplained surge in brightness that unfolded over mere weeks. Why now? Why this much? Why so suddenly? Some scientists speculate that Betelgeuse may be entering its final, most volatile phase. A convulsive moment in time where its internal fusion processes grow increasingly unstable. A moment where the equilibrium between radiation and gravity begins to crack. At the core of Betelgeuse, fusion reactions are battling for control. The heavier elements being fused, carbon, oxygen, neon, signal that the star is nearing the final chapters of its existence. And once iron begins to fuse, the battle ends. Gravity wins, and the star collapses in on itself, triggering a titanic supernova, one that will briefly outshine entire galaxies. If Betelgeuse were to explode, the flash would be visible on Earth even in broad daylight. It would shine brighter than the full moon and dominate our skies for weeks. But despite its relative closeness in cosmic terms, there would be no danger to Earth. Instead, we would be gifted with a rare, breathtaking cosmic display, a celestial finale to a giant's life. But is that what's really happening? Could this sudden brightening be the first rumble before the storm? Another theory suggests that the brightening may be due to an immense convective cell, a massive bubble of hot gas rising from the interior to the surface. These surface eruptions, driven by turbulent plasma and chaotic magnetic fields, can temporarily alter a star's brightness by ejecting enormous amounts of matter into space. Or perhaps it's related to a massive stellar eruption. In 2019, Betelgeuse underwent a mysterious dimming event, which some astronomers attribute to a colossal dust cloud expelled from the star that temporarily obscured its. And then? There's the magnetic field. That unseen architect of chaos and order. An invisible force threading through Betelgeuse like ancient veins of lightning, whispers of power crackling beneath its swollen crimson skin. Could the true cause of Betelgeuse's eruption lie here? Buried in the shifting, tangled net of its magnetic structure, deep, elusive, and misunderstood. Magnetic fields in stars are like the subconscious mind, powerful, hidden, and often unpredictable. They twist and writhe with intensity, forging paths of plasma, bending space, creating storms that dwarf anything seen on Earth. But Betelgeuse is no simple star. Its magnetic field is not a gentle stream, it's a roaring, unstable tide of cosmic energy, in flux, always changing, always evolving. Recent models hint at something astonishing, a magnetic dynamo beneath its surface, pulsing like a heartbeat, generating chaos from within. What if that field suddenly shifted? What if it realigned, twisted inward, or snapped? Such an event could rearrange the way energy flows from the core to the outer layers, unleashing a violent wave of stellar fury. A storm that could light up the heavens. A cosmic scream we now see as a 250% surge in brightness. This is no ordinary phase. This isn't just another fluctuation in an aging star. This might be a threshold? A turning point in the life of a celestial giant. The moment where a star stands on the edge of its own mortality, and flares one last time before its collapse. The James Webb Space Telescope watches with unblinking eyes. Hovering in the vast silence of space, it gathers every photon, every pulse, every flicker of light from Betelgeuse. Its instruments see deeper than anything before it, beyond the dusty veils and plasma clouds, into the furnace of the star's very soul. With each new reading, more of Betelgeuse's mysteries are revealed. But with every answer, new questions spiral into view. Could this sudden change be the whisper before the scream? The final inhale before the most dramatic exhale in the universe? Are we on the brink of witnessing a supernova, a rare and cosmic death throe, played out before our eyes? If Betelgeuse explodes, it won't just be an astronomical event. It will be a spectacle unlike anything humanity has ever seen. The light would burst across our skies, brighter than a full moon, visible even during daylight, casting shadows at midnight. It would burn in the sky for weeks, perhaps months, a firefly trapped in eternity, telling us that a star has died. And yet, we would not be in danger. We would be spectators, not victims. The explosion, though colossal, would be distant enough to awe, not harm. It would be the closest supernova in recorded human history, an event so rare, it might only happen once in 1,000 lifetimes. A celestial performance, where the curtain rises for the last act of a cosmic titan. But what if this isn't the end? What if Betelgeuse is not dying, but transforming? Becoming something new? What if this is a rebirth cloaked in brightness? A phoenix made of plasma and light? The truth is, we don't know. That's what makes it beautiful. That's what makes it terrifying. For now, Betelgeuse remains a riddle. A mystery